Welcome back to my channel. In this video, we will see mastering exploratory data analysis, visualizing data with bar graph, contingency table, and histograms in Python and R. Let's start with the introduction. In this video, we will explore exploratory data analysis (EDA) techniques, focusing on visual methods such as bar graph, contingency tables, and histograms. These tools are essential uncovering patterns, trends, and insight in your data using R or Python. Additionally, we will delve into numerical summaries like measure of central tendency and dispersions, assess data distribution, and identify potential outliers or anomalies. Furthermore, we will discuss how EDA helps in detecting missing values, evaluating relationship between variables through scatter plots or correlation matrix, and preparing data for machine learning or statistical modeling. We will also touch on advanced visualization techniques such as box plot and pair plot to provide a deep insight into variable relationships. By incorporating these methods, VDA serves a critical first step in understanding the structure and quality of your dataset. By the end of this session, you will have a practical understanding of how EDA can transform raw data into actionable insights, setting a strong foundation for further analysis and modeling. Whether you work with small dataset or tackle big data challenges, the principle and technique of EDA will empower you to make informed and data-driven decisions. What is EDA? Exploratory data analysis is a vital process in data analysis that focuses on summarizing the main characteristics of a dataset through descriptive, static, and visualization techniques. It allows analysts to uncover patterns, trends, and anomalies, provide initial understanding of data structures and quality. EDL laid the groundwork for informed decision making and effective model building by identifying key insights. By utilizing tools such as histograms, stat plot, box plot, and correlation matrix, EDL make it easier to detect relationship, outlines, and data distribution patterns. This step is essential for redefining hypotheses, addressing data quality issues, and preparing the dataset for advanced analytical tasks. Now, we will see importance of visualizations. Visualization play a key role in EDA as it transforms complex data into accessible insights. It allows analysts to quickly identify trends, outlines, and patterns, facilitating better decision making and deep understanding of dataset. By presenting data in a graphical format like histogram, scatter plot, and box plot, visualization simplifies the interpretation of relationship between variables and highlight area requiring further investigation. This visual approach not only enhances clarity but also speeds up the analysis process, making it easier to communicate findings to both technical and non-technical audiences. Moreover, visualization is invaluable in spot data quality issues such as missing value or inconsistency that may not be evident in raw data tables. It supports hypothesis generation by revealing unexpected patterns and correlation, guiding further analysis. Ultimately, effective visualization bridges the gap between the raw data and actionable insights, empowering analysts to make informed, data-driven decisions. Bar graph overview. Bar graph is a powerful tool for comparing different categories of data. It displays category data with rectangular bar where the length of each bar is proportional to the value it represents. This makes it easy to visualize difference at a glance, providing a clear and immediate understanding of how categories compare in terms of frequency, count, or any other measured value. Bar graph can be oriented horizontally or vertically, with a choice depending upon the dataset and the best way to convey the information. Bar graphs are particularly useful in highlighting trends, making comparison, and identifying outliers with a dataset. They can represent single variable data or group to show comparison across multiple categories. By incorporating color codes or annotations, bar graphs can tailor to emphasize key insights, making them essential tool for exploratory data analysis. Now we will see how to create bar graph in Python. In Python, libraries like matplotlib and c1 are excellent for generating bar graph. Use plt.bar from matplotlib or sns.barplot from c1 to create visually appealing and informative graphs, allowing for easy comparison of categorical data. Matplotlib provides a straightforward approach to product graph, offering flexibility in customizing color, label, and access. Seaborn, on the other hand, enhance their visual with a statically pleasing design and built-in functionalities for summarizing data to aggregate statistics such as mean or median. While creating bar graph, it is important to choose appropriate color and label to ensure clarity and readability. By leveraging this tool, you can effectively visualize categorical data and communicate insight with impact. Now we will see how to create bar graph in R. In R, the ggplot2 package is widely used to create bar graph. By utilizing functions like geombar, you can easily visualize categorical data where each bar represents a different category and its height corresponding to the frequency or count of observation within the category. One of the advantages of using ggplot2 is flexibility. You can customize your graph with various themes, colors, and labels to make them more informative and visually appealing. Additionally, ggplot2 allows you to adjust the axis label, add title, and modify appearance of the bar, such as changing color or adding patterns. Contingency tables. A contingency table is a matrix that display the frequency of distribution of variables, showing the number of occurrences of each combination of a categorical value. It helps in understanding the relationship between two categorical variables by organizing data into rows and columns. Each cell in the table represents the count of data points that fall into corresponding category combinations. This structure allows for easy comparison of the frequency of different category pairs, offering insight into potential association or independence between variables. Contingency tables are especially useful in hypothesis testing, such as I-square test, where assess whether there is a significant association between two variables. This technique is widely applied in fields such as including marketing research, social sciences, healthcare to examine the categorical data and make informative decisions based on their findings. Now we will see how to create contingency table in Python. In Python, the Panda library provides the cross-table function that is easily create contingency table. This function is powerful for analyzing the relationship between two categorical values, showing the frequency distribution of the variable in the matrix format. The row and the column of the table represent the categories of two variables. The values in the table represent the count of or the frequency of each category combination. This makes it easy to identify pattern dependency or association between variables. In addition to basic frequency table, cross-type also supports variable options like normalizing the table to show proportions, adding margins to compute row and columns. You can further enhance the visualization of the result by using heat map or stack bar charts. The next is histogram. Histogram is a graphical representation of a distribution of numerical data. It divides the data into bins or intervals, where each bin represents the range of values. The height of each bar indicates the frequency of data point within that bin, helping to visualize how the data is distributed across different value ranges. Histograms are particularly useful for understanding the shape, spread, and center tendency of the dataset. By analyzing a histogram, you can quickly identify patterns such as skewness, multimodal distributions, and presence of outliers. It also allows for easy comparison between different datasets or subgroups. Additionally, histogram can help in determining the appropriate statistical technique for further analysis such as normality test. Overall, histogram provide a clear intuitive way to examine and summarize the key characteristics of numerical data, making them essential tool in exploratory data analysis. Now we'll see how to create histogram in Python. In Python, the matplotlib library provides a plt.hist function to create histogram, which visually represents the distribution of numerical data. Function take a dataset and automatically divide into a specified number of bins, where each bin represents a range of value. You can modify parameters like color, transparency, edge color, width of the bar, title, access levels, and legends can be also added to improve clarity. Customizing your histogram ensure that effectively communicates the underlying distribution and help in identifying trends, skewness, and outlines in your datasets. So here we come to our conclusion. Mastering exploratory data analysis with techniques like bar graph, contingency tables, and histogram is crucial for effective data analysis. By leveraging this visualization tool in R and Python, you can uncover valuable insight, identify trends, and recognize patterns that may otherwise go unnoticed. These techniques allow you to visualize distribution, explore relationship between variables, and detect potential outliers or anomalies. Incorporating EDA into your workflow not only enhances your understanding of the data but also help in preparing the dataset for more advanced statistical modeling or machine learning. Whether you are dealing with missing value, skew distribution, or data inconsistency, EDA provides a robust foundation for addressing these challenges. By mastering these tools, you can confidently navigate through raw data, ensuring more accurate and informed decision making, ultimately leading to more effective business strategies. This is also for the video. If you like the video, please like the video, do comment. Thank you.